Hello, today we're going to be talking about mass and weight. And as we told you guys earlier, whenever you're talking about mass, we're talking about the matter contained in an object or in a substance. For example, you have a box here. This box, we would say it has a mass of 5 kilograms. Now, when you want to talk about what the weight is, you have to talk about the force of gravity acting on it, maybe on the Earth's surface, or it may be on the moon. But the mass remains the same thing because the mass doesn't increase, neither does it decrease anywhere you go. So the mass is the same thing, it's constant and is measured in kilograms, while the weight is the force of gravity on that thing. Now, let's say, for example, you're on the Earth's surface. We already know that the gravitational field strength of the Earth's surface is 10 Newton per kilograms. So the weight of this is going to be weight. The formula for weight is mass times the gravitational field strength. So the weight of this is going to be 5 kilograms times 10 Newton per kilograms. So 5 times 10 kilograms cancels kilograms out. So it's going to give you 50 Newton to be the weight. So that tells you the weight is calculated in Newton. I mean, the unit for weight is Newton, while the unit for mass is kilograms. Now let's face the solution. Let's face solving the problems we have here. Now we say we have a person who has a weight. The weight of the person is 400 Newton. 400 Newton is the weight. And we don't know what the mass is because we're told to find what the mass is. And we already know the gravitational field strength of the Earth is approximately 10 Newton per kilograms. So this is very simple. Now we're going to say the weight of this person equals to the mass times the gravitational field strength of the Earth's surface. Now we're given the weight to be 400 Newton equals to mass, which we don't know, and times the gravitational field strength, which we know to be 10 Newton per kilograms. So to solve this, we need to divide through by 10 Newton per kilograms because we need to leave mass alone in the other side of the equation. 10 Newton, 10 Newton per kilograms. So divided by 10 Newton per kilograms. So this is going to cancel this out, and 10 has to go in 440 times. So the kg, the Newton has to cancel the Newton out. So now you have the remaining to be 40 kilograms. So the mass now is going to be 40 kilograms. You can check out, maybe you got your answer right. So let's go back to what the equation says. The equation says the weight equals to the mass times the gravitational field strength. We know the gravitational field strength to be 10 Newton per kilograms, and the mass now is said to be 40. Now let's multiply these two together. Maybe it's going to give us 400. Now that tells you got your answer right. So now let's move to the next question. It says the value, now this person to be considered here is not on the Earth's surface, is on the moon. That was already I told you earlier. When you have a mass, the mass remains the same thing anywhere you are, but the weight can change depending on the location where you find yourself. For example, now we say the moon has a gravitational field strength. The gravitational field strength or the gravitational pull of the moon is 1.6 Newton per kilograms, and we want to know what the weight is. Well, we already know what the mass is. The mass is given to be 30 kilograms. So to find this, I think the equation still holds here. It's going to be weight equals to mass times the gravitational field strength. So the gravitational field strength is given to be 10, as we already know before. Now, we're considering the moon here. So the gravitational field strength is going to be 1.6 Newton. So now this is 1.6 Newton per kilograms. And we know the mass to be 30 kilograms. You multiply this by this. So now let's solve it together. 30 divided by 1.6. let's ignore the decimal point now. 6 times 0 is going to give you 0. 6 times 3 is going to give you 18. 1 times 0 gives 0. 1 times 3 is going to give you 3. So this is going to give you 8480. Now don't forget we had a decimal point which we removed here before, so we need to return it back here. And if you return it back here, now it's going to go back here also, because we have to count back with 1 decimal point. So that tells you the weight of this person, the weight of this astronaut is going to be 48 Newton, because we say the unit for calculating weight is going to be Newton. So that tells you this person has a weight of 48 Newton on the moon. Now from here I want to infer some basic things so that we can understand the fact better. Now I told you before, we can have a mass of 5 kilograms. The mass will have to be the same thing everywhere you are. If you're on the moon, if you're on the earth, if you're on the Pluto, anywhere you are, the mass will remain the same thing. But the weight would change depending on the force of gravity of that location. We need to know now from here that look at the mass here. Let's take for consideration here. Now here we have the mass to be 400 Newton, and here we have the mass to we have the weight to be 400 Newton there, and we have the weight to be 48 Newton here. That tells you this person okay, now let's find a solution here to solve, to explain what I want to say better. Now let's say for example you have a person. Now we want to know what will be the weight of this person if you have the person on the Earth's surface, which has the gravitational field strength to be 10 Newton per kilograms. Now let's say for example the gravitational field strength on the Earth's surface is 10 Newton per kilograms. We want to know what the weight of this person is going to be if he is having the same mass on the Earth's surface. Now it's the same formula. We say weight is going to give you what? It's going to give you mass times the gravitational field strength. Now the weight is going to be, what is the mass? 30 kilograms times the 10 Newton per kilograms. Now the kilograms cancels out kilograms, and the weight of this person at the Earth's surface is going to be 30 Newton. Now the point I'm making here is this person weighs more on the weight on the moon is quite lesser than the weight on the Earth. Sorry, I'm making a mistake here. This is going to be 300 Newton. So the weight of this person on the moon is quite lesser than the weight on the Earth. And I told you the gravitational field strength of the Earth is bigger than the gravitational field strength of the moon. And the reason why this is occurring is because I told you earlier, the more massive the planet is, the greater the gravitational field strength. And it's from this point we can understand that the Earth's surface is more massive than the moon. And that is the point, and that is the reason why the gravitational field strength of the Earth's surface is quite greater than that of the moon. And I told you, once the gravitational field strength of a location is higher, then we will have more weight there than a place where we have a lesser gravitational field strength. And I told you that the moon is less massive than the Earth's surface. The more massive a planet is, the more the gravitational field strength of that planet will be. So if we want to consider some other planet now, we have to know what the weight to be there, then to know maybe it's more massive than the ones we considered here. I hope this was really helpful. Thank you for listening.